Hi guys, so this is going to go over lesson 8.1, which is called Differential Equations. Okay, so the definition here of a differential equation is an equation that has a derivative in it. Okay, so the idea is that we are going to either find a general solution, which is basically the function like in terms of y, like solve for y, so you basically are going to integrate it and go back, so this is giving you the derivative of it. And so a general solution is because you're going to have a plus c, the idea is that when you integrate you have to have some constant, okay, versus a particular solution, which is if they give you some ordered pair, then you can figure out what the c is, and then that gives you a particular exact equation. So here are the basic steps here for solving for differential equations. Okay, so the first thing that you want to do, and it's not always necessarily, is you're going to have to change your notation and change that derivative into dy dx. Okay, the second step is going to be to multiply both sides by dx. Okay, so we'll just kind of keep with that idea, and then you're going to third separate your variable. So this is the most essential or critical step, so you want to make sure that all of your x's are on one side and all of your y's are on the other side. There we go. Okay, so x is on one side, y is on the other side. Once you have your variables separated, you can then integrate both sides and then solve for your y. Okay, there will be a plus c. You'll add the plus c on the x side only. Okay, when you do your integration. All right, so here we go. So we are going to find the general solution, which just means we're going to figure out, we're going to integrate this and have a plus c at the end. Okay, so my first step is to rewrite the dy dx. This one is already written that way, so we're going to start by multiplying both sides by dx. Okay, so I can say I have x times dx plus 2y dy dx times dx, and that's going to equal 0 times dx. Now notice, I did only multiply this side by dx, and I just kind of distributed that through so it's being multiplied into every term. Okay, so if I simplify this just a little bit, we have dx, or x dx, plus 2y dy, notice those cancel, and then this other side is just going to stay as 0. Okay, so once I've simplified that, my next step is to separate the variables. So I want my x's on one side and my y's on the other. So I'll just go ahead and subtract the x to the other side for this one. You could go the other way if you wanted. Okay, so all my y's are on my left, all my x's are on the right. So once that happens, I can then integrate. So I'm going to integrate both sides. So I'm going to go up here. The integral of 2y is 2y squared over 2, so hopefully you can go straight to the fact that just makes 2, or y squared, excuse me. The integral of negative x is going to be negative x squared over 2, which I'm going to say is negative 1/2 x squared. Okay, so since we're integrating the x piece, we're going to add the plus c here. And my last step is, if I'm solving for y, I would have to square root this. Okay, so this is kind of an interesting scenario where I would have to have a plus or minus here, because the idea is I'm solving an equation and I took a square root, so I'd technically need a plus or minus version. Okay, so that's why it's a general. We don't know exactly if it's one or the other. Okay, so this next piece is just asking us to write it as two separate solutions. So we'd say one is the positive version, and the other one would be the negative square root version. Okay, pretty simple there. Okay, so question number 2 kind of has the same idea, but starts out with maybe a more complicated idea. Okay, so it says to find the equation of a function which contains the point 0, -3, so that means we're going to end up finding the c value, and whose slope is this, okay, for each of our x and y values. So, if I'm given a slope, I know what? I know my first derivative, so I know that dy dx is equal to x times e to the x squared over y. Okay, so this is going to be my differential equation that I'm going to solve for y. Okay, so the same steps as I did up here. Okay, so my derivative piece is already in dy dx, so I'm going to start by multiplying both sides by dx. So that's going to cancel there. So I have my dy here. On this one, nothing cancels out. Okay, so the next step is I want to get all of my y's on, let's go to the left side, and all my x's on the right side. So I've got this y down here, so to get it to the other side, I'm just going to multiply the y over. So now I have y dy is equal to x times e to the x squared dx. Okay, so I can look at this, all my y's are on the left, all of my x's are on the right, so I can now integrate. Okay, so the integral of y is 1/2 y squared. Okay, the integral of this, now this one is going to be one of our rules on our sheet, and of course I don't have it in front of me, but I'm going to go with, it's one of the e's. So I'm going to ignore this x for a second, and I'm going to divide by the derivative of the exponent piece. So the derivative of x squared is 2x, and I'm hoping this x cancels out if that was done correctly, and it does in this case. I'm dividing by that hook-on factor. Okay, so I add the plus c on the x side, so this basically is going to give me 1/2 y squared is equal to, let's write this as 1/2 e, and then to the x squared plus c. So now again, if I'm going to solve for my y, I can kind of ignore my c for a second and pretend that I don't have it yet. I notice I have a 1/2 on both sides. Okay, if I divide by the 1/2, they cancel out. So I have y squared is equal to e to the x squared plus c. Okay, now the reason I can ignore the c is if I did have a 1/2 here, or that was in front of this, the idea is that this piece is a constant. If I have 1/2 of a constant, I still have a constant. So I can still call this c, I just know it's some c number. It doesn't matter what number is in front of it. Okay, so again, my last step here, I'm going to square root. So since I'm solving an equation, I need a plus or minus here. Plus c. Okay, so there is my general solution. At this point, I can use my point, the 0, -3. So this is kind of an interesting idea. I know that my x value is 0 and my y value is -3. So if I plug this in, when I'm thinking about a square root, is it possible for a square root to equal a negative number? Okay, no. So I know for this plus or minus thing, it has to be a negative for the other side to be a negative. It's the only way it'll hold true. So now I can plug in 0 into the x, so I have 0 squared plus c. So now I'm just solving for the c, just very basically. I can say, I've got a negative on both sides. We got e to the 0 power. We can square to get rid of that. So that makes 9. And e to the 0 power is 1. Whoops, excuse me, I didn't mean to write that square root. 1 plus c. So I think we would all agree that the c value is 8. So we can go back to our equation, plug the c value in. I know I have to have a negative square root because our y value is negative. That was the only possible way to make that true. And there is my particular solution. Okay, not too bad. Alright, so same idea here. We've got the idea of the general versus the particular. So let's start with the general. So the first thing I want to do is make sure I'm in a dy dx. We're good there. So then I'm going to multiply both sides by dx. Okay, so this is going to cancel. My next idea is I want to get all of the x's on one side and all of the y's. I notice right here I have this dy dx. So what I'm going to do here is I'm going to pull this dx out like a greatest common factor. So I'm going to have y minus 2. I don't know why I feel like I just need to put the dx at the end. So x dy. So now I got the y's and the x's on the complete opposite side. So I'm going to have to divide by the x to get it to this side, and divide by the y minus 2 to get it on the other side. So this is going to be 1 over x dx equal to 1 over y minus 2 dy. Okay, so now my x's are all on the same side, my y's are all on the same side. My next step is going to be to integrate. Okay, so when I integrate this, I have a 1 over x. Okay, so the integral of 1 over x, let's move this up here, is the natural log of the absolute value of x. Okay, and I'll add a plus c on my x side. And the integral of 1 over y minus 2 is the natural log of y minus 2. Sorry, that's kind of light. So to get rid of the natural logs, I'm going to convert and put an e and put it into exponential form. So I'm going to have e to the natural log of x, absolute value of x, plus c, and then that's going to equal e to the natural log of the absolute value of y minus 2. Okay. So at this point, this is kind of an interesting technique here. What I'm going to do is I'm going to use my properties of exponents. So if I have a natural log of x plus c up here, I can separate this out and say that this would be equivalent to e to the natural log of x times e to the c. Okay, so the point in doing that is to separate that c off. And so then I can simplify a little further, because if we have this piece in e to the natural log, those cancel. I get an absolute value of x times my e to the c. And same thing on the other side, this is going to end up being the absolute value of y minus 2. Okay, so from here, we have an absolute value equaling an absolute value. So we know that both sides are going to be positive. So that's going to work out okay. So we're going to have x. Sorry, my stylus is dying. E to the c is equal to y minus 2. And now that I can solve, I just am going to add that 2. So I'm going to switch the sides here. So we got, I'm going to put my constant piece in the front. So e to the c x plus 2. Okay, now let's talk about this really quick. Remember that that c idea is just some constant. We don't know what it is. It's a constant. Okay, so instead of making it super complicated, we're just going to let it be some constant and make it very simple. So we're going to let that some constant still be c instead of e to the c. Okay, so anytime you have something with, oh, my stylus just broke. There we go. Okay, so now for b, it asks us for a particular solution, which is kind of the same way of asking, let's figure out what the c value is so that we don't have this some general equation. So this is our x, this is our y. We're going to use the equation that we found from a. So this is just going to be 1/2 is equal to c times 1 plus 2. So I'd subtract 2. Since we're doing halves, I'm going to call 2 4/2. So now 1/2 minus 4/2 is negative 3/2, and that's going to be our c value. So our particular solution is going to be y equals negative 3/2 x plus 2. Okay, so this is not super complicated, but it is important stuff for you to know. If you are willing to do problems 1 through 8, that will be worth 1 full extra credit assignment. Okay, it'll be due on either Monday or Tuesday when I see you next.